Next example. Sometimes tests fail. You first look at this one. You want to try the limit comparison. But when you set it up, because it does appear to be mainly like a geometric sequence, 1 over 4 to the n. So if you did this comparison, set up the ratio, thinking that this would work, what you end up with is this. Which heads to 0. So our limit comparison test does not apply. The conditions are not met. It has to be a positive number. Okay, so doesn't really prove anything, except that the test is not applicable. So you go back to square one here. And maybe we can show with the integral test, but using integral test, you'd have to check a few things. First of all, and these are met, f of x is positive. It is continuous. And there, it is decreasing. That takes a little work. You have to find a derivative to show that, but it does appear to be decreasing as long as x is greater than approximately 0.2213. You might want to check on that just to be sure that you can see that. So that's a little bit of work right there. Second thing is you'll have to set up the integral itself. So you're going to go from 1 to infinity, 2x plus 1 with a 4 to the negative x. This is going to require integration by parts. So I get you started on that and show you what happens. You'll let the u be equal to the 2x plus 1, and then the du is just a 2 dx. And you'll let the dv be the 4 to the negative x. And which means that v is going to be negative 1 over natural log of 4. Oops. Natural log of 4 e to the negative x. Okay, and putting these together, again, so this one's a lot of work. You're going to have 2x plus 1 times that is uv, so we'll have this minus, and we'll write this as natural log of 4 with an e to the negative, well, e to the positive x then underneath here, plus, that was uv minus v du, so it'll be plus 2 over the natural log of 4 e to the negative x. And that's an integral. Okay, and now you can check this. We have to. This is all. This first part is from 1 to infinity. You'll have to check that. It's not too bad. You can use. That's a positive x, by the way. I have changed it. You can use L'Hopital's rule on it. One application you should be fine. This was a 4 to the x down here. Let me fix that. Oh, I can erase that or not. Yeah, let me fix that a little bit there. That should be 4 to the x. in there. And this one, I don't know, how did I end up with e to the x in here? Sorry about that. I don't want to redo this whole thing, so I'm just going to fix that. Sorry about that. This is 4 over here. So used to working those e to the x's. Okay, and again, same thing with this other one in here. So let me fix that. Okay. That's a 4 to negative x. Okay. In any case, you'll have to find these. This limit, L'Hopital's rule will show that it'll be finite, some number. The infinity gives us a 0, but we do have a 1 stuck in there for that x. So you'll get some number. Over here, you'll have to do another integral, integrating this particular integral. So this whole thing heads to a constant. All right, constant. This heads to, let's see, -2 over natural log of 4. You'll have that squared because you'll need a couple of those for this integration. 4 to the negative x, and that's going from 1 to infinity again. And this too, once evaluated, you'll see that 4 to the negative infinity ends up as a 0, and you'll get a constant, so another constant. Okay, and that's all that we need for the integral test to be significant, is the word? No, conclusive. So we get convergence. Now, later on, you know, convergence. Later on, we'll have a better test than this one. This is not my favorite for this particular problem. Integral test is not always easy to apply. So, but it got the job done here. Later on, we'll have a better test than this one. So don't feel like that it's that bad. It's not really that bad. Okay.